Bullshit, I can't hear you. Sound off like you got a pair.
And a happy Saturday to you too, Gumby. Hey, Samantha and Killa. Happy Saturday to y'all. Sorry I'm a bit late tonight. I had to finish up some stuff that I was helping Sock with, and just took longer than I had anticipated. Getting everything set up here. We'll get started in just a minute, everyone. Hope everybody's having a fantastic Saturday. I had a pretty good one. What is up, Mr. Right Guy? Hope you're having a fantastic Saturday also, man. I had a pretty good one. Mostly well, actually, no, I think about it. It was not a chill out day. It felt like a chill out day because I was doing stuff around the house instead of being out of the house all day. Yeah, that's like poutine is like it's like brown gravy and French fries, isn't it? It's curd cheese? Hold on. Hold on. Let me boot this thing up. Let's see if the screen share will actually work. Hey, there it goes. All right. Hold on. I gotta look this up then, because I'm probably thinking of something different. Hold on. Oh, so it is French fries, but there's also cheese curds on top with hot brown beef and chicken gravy. Nice. I've never been a huge fan of cheese curds, but I'll be honest. The French fries and the brown gravy do sound pretty badass. It is freaking cold. What is it right now? It's like 35 in Dallas, and so that was actually part of what I did today with Sock. Was we went and cleaned out the deep freezer and de-iced it, which is like our yearly ritual. And so we wait till we've got like some really cold day, and that's what we did. I want this to go away. Hang on. Move that there. All right. What if we're still connected? Yeah. Let's see. Hey, cool. So the server's still up. Nice. All right. Let me double check something here, because for some reason... Ah, there we go. So the test box is open. Nice. All right. Let me go do this. I was actually doing some dev work on Ghostwriter earlier, so if you're wondering what the extra stuff is, that's what I was working on. Let's see here. Let me get this all kicked off. Let's get our seed run going. But yeah, that was pretty much what I did today. Is I just did stuff around the house with Sock. We were, oh god, what did I just click? I don't know what I just did. Hang on, I gotta get the IP address. I'm hitting everything wrong tonight. Hold on. There we go. Let's grab this, drop this right. Yeah. Yeah, and then after we got all that done, I did a little bit of work today, because like I said, I've been doing some dev work, because I had some extra features I wanted to personally add to Ghostwriter. So I've been doing that because I could. I've been having some fun here. So after all that was going on, we start a new thread here. New thread. Run. Let me get to the exploit agent so we can just have it chill out there. But yeah, so did that today, and then because it was nice and cold, so we cleaned out the freezer, got all the ice knocked out of it, and reorganized it, because it just slowly descends into chaos. I start with great organization around January, and then come July, it's just a mess. So that's the kind of the yearly thing that Sock and I do, is to go clean out the freaking freezer and figure out what all we've got in there. And then did a little bit more work today, working on adding some cool stuff over to Ghostwriter, because it has a spot for keeping notes, but I wanted to be able to expand on that. So I'm tinkering around with it. And then after the kids woke up, took them over to my father-in-law's house, and then we worked on fixing Agent Zero's bike. Finally got all the parts in. But it was funny because the cylinder, the whole engine was built, what's called a too fast 50 build. And I ordered a replacement cylinder, or a replacement piston, even though I didn't need one, but I wanted to have one on standby. So it comes in and it looks different. So I emailed the lady who I talked to whenever I'm ordering this stuff, and I start getting angry text messages from her husband, who I try not to bother because basically he doesn't. My impression, this probably is not an accurate impression, is that if you don't understand highly detailed aspects of like what you're doing, which I freaking don't. I am an extra set of hands and I'm learning how to work on these engines from my father-in-law, who's been doing it for like 40 years. But I don't feel comfortable text messaging him. So I text messaged the other lady whose name is Amy. And I got a very long string of like angry messages like, don't message her for tech support. Here's my number. You text me. Da-da-da. By the way, that piston's fine. And here's why. He gives me the reason. I'm like, yes, sir. Right away, sir. I'll text you for any text issue, sir. And that literally just happened as I was getting ready to come on stream. It's fine, Peaches. You already went outside. No. No. Come here, Peaches. Hang on one sec. Come here. Come here. Let me look at you real quick. I've noticed something important about Peaches. Come here. Come here. Look at your eye. Come here. Okay. Her poor Peaches, she's had some kind of like a sinus problem, and it's been making her eye get all like goopy. Poor little puppy. That's the average temperature up in Quebec. I know, but I've had cousins come visit me from Newfoundland down here in Texas, and even they were complaining about how cold it was. They were shocked. What is this? Unbound local error? That is a new error. Where did it occur? In the exploit agent? What? Where did this happen? Oh, maybe line 50. Okay, let's go look at that for a second here. But it's -4 Celsius in Quebec. Dang. Yeah, but Killa, it never. Well, I mean, I want to say that when I was in Las Vegas, it was really cold there. It was colder in Vegas than it was here. I was like, okay, yeah, you're in the desert. There's not as much heat going on, right? And so. Guy, I actually have been meaning to tinker with OpenCode. There's actually two. There's OpenCode, and there is another one that I want to look at called Factory AI. And this was one that actually, when I was taking the course with Jason Haddix, he mentioned, I messaged him again to figure out like what the name of the course was. Or what not the name of the course, what the name of the tool was. And this is what he mentioned to me. And they're, I think, really trying to position themselves as like a Claude Code competitor. And you can set it up to where it's bring your own keys and everything. I was just tinkering around with it a little bit earlier today. I haven't had a chance to dig into this one, but this one and OpenCode are the two I'm wanting to look into. The key difference is I've had Claude Code doing a lot of stuff that was not coding related. It was coding like assisted. I'm having it do tasks that are way outside the coding realm, but it is taking those tasks and kind of making them codified a bit, doing some little bits of code, but it's not bad. Let me see. Does OpenCode have a web UI? Because I thought OpenCode was purely command line. Oh, okay. Cool. Like I said, I haven't had a chance to dig into it yet. I've been messing mostly with Claude Code and just burning up my own recent one. In fact, hang on, there was a guy who did this. Check this out. Reddit, what was it? Claude Code usage cost analysis. Let me see if I can find it real quick. Actually, this is not what I was looking for, but that could be interesting. What did this guy say? Only load these two and ignore the rest of the code base. Oh, okay. Killed the mega sessions. All right, interesting. I'll have to look at that one later. But no, there was a guy that went through and actually did an analysis of how much you're spending on the various licenses and like how much you get for it. But I'm also not a huge fan of vendor lock-in. So I'm wanting to... So I want to start messing with OpenCode more and using a fleet of different language models. Probably through OpenRouter as it comes through that. All right, let's go see what happened in our exploit agent here. So we were going to look at line 150. So at 150, for some reason, it says the output task here. Oh, so there's an issue with output task. Let me see. This is another thing I was thinking about re-architecting in here, was going through and making this beginning like agent entry logic very well defined. Because right now it's kind of a mess. Oh, wait, hold on. That web server, though, if I remember correctly, Guy, wasn't there just a CVE just issued for that because the web server was bound on all interfaces? Yeah, here we go. OpenCode, open source AI agent. So prior to 10216, OpenCode automatically starts an unauthenticated HTTP server that allows any local process. Okay, so it was at least local. To execute arbitrary shell commands with the users, with whatever the user's privileges were. So yeah, they did just go fix that. I was like, okay, that's good to know. But you're telling me that OpenCode has 4 models you can use for free? There was a couple of different ones. Hang on, let me see if I can find it real quick. There's a fellow on X who I disagree with on a lot of stuff, but he actually had a really good suggestion. Let me find it real fast. His name's Ahmed. Yeah, here we go. He was saying, using OpenCode with GLM 4.7 and Minimax M.21, you get a really close experience, especially if you have GPT-5.2 High in charge of reviewing and planning. So that's what I was looking at, kind of messing with it. I've been meaning to try it, Guy. So OpenCode is definitely on my list of to look at here probably this coming week. I'm going to go mess with it some more. I do actually, it's kind of crazy because as I've been using Claude Code to go do some more coding tasks, and it's actually been doing a really good job. I have noticed a little bit of a quality difference between Opus and Sonnet. But at the same time, I've also noticed that you can get a lot more work out of Sonnet because of the cost differential. But it seems like the work is more accurate with Opus. So there's a little bit of a trade-off there. But it's making me think about things far differently. I do like doing this and getting down into the bits and the bobs and figuring out what's happening. But also, I'm like, it's very interesting. It's very, very interesting. I'm going to keep playing with it some more and seeing like what else could I don't like to call that vibe coding. So for me, vibe coding is if I had an intelligent completion assistant sitting here or doing things like I put in, I don't know, like a comment right here. So like, this function, this function does X, right? You throw that in there and then it just kind of like, it spits out what the function is supposed to do. That's kind of what I was considering vibe coding. What I had Claude Code doing, I'm going to equate more to Ralph Wigguming, where it's just, I'm letting it fly. All right, let me think about this. Create the exploit task. I need to plan out where these are going in here. Okay, so first section here is if the task gets passed to this agent, it bails out. Otherwise, if the input task status is working, I did hear about Linus liking anti-gravity. Is anti-gravity the one from Google? Yeah, I'm pretty sure that is. Yeah, Google anti-gravity. Yeah. I don't know, man. With the next generation IDE. I will say this, though. At least one thing Google does well is they don't usually put out really crappy software. It looks interesting. You know, what is this? What is this play button thing following my mouse? Get away. Shoot. Anyway, since I've got Gemini Pro for a couple months, I will probably go spin it up and test it out. Have some fun with it. But one of the things I like about it is I can, with proper usage, that's actually what I've been sussing out right now on the Claude Code front, is what's the proper, like, kind of somewhat optimal way to do it. And so I have this tendency of, I'll do something like this. Oh God, what is this? What in the hell? That is, don't tell me my color scheme got screwed up. Oh, there we go. God, like, what the heck just happened here? Let me clear that out. And one of my bosses finally realized this about me, and that is what they expect whenever someone is trying to learn a new technology stack is they expect them to go like this roughly, right? Like, and this right here being whatever their output is. That's not exactly what I do. I do a lot of tinkering. So whenever I'm learning something and I'm messing with it, my output kind of looks like this. It looks almost like a freaking heartbeat. And then it does this. And then just goes sideways. And so what I'm doing here is all of this is my tinkering time. I'm doing lots of little small tests. And then right around mirror, I find all the ways that fail at putting it together, and then I find that optimal way of doing it, and it just skyrockets. It's the same thing I've done with lots of different technologies. So after so many cycles of that, I've learned this about myself. This is what happens. It looks really cool, I screw it up. It looks really cool, I screw it up. Looks really cool, I figure out how to put all the screw-ups together in the correct formation, and boom, goes like that. So that's normal people. This is the Blaise Bits way. For example, what we're just looking at right here. Okay, so for some reason the output task, when it reaches this point, has not been set yet. So where else do we reference output task? Here's we're adding a blank entry to the host table. Let me put another note here. No entry means no IAE. So skip pre-flight. We take that out. And then here, let me see if there's anything else in here I need to double check. Okay, so yeah, it looks like I'm just forgetting to do that. So when it gets to this point right here, oh, I think I see what's happening here. So when this executed, hold on, that doesn't track with what this should be doing. Let me pull up the trace here real quick. So exploit agent should have run. See what this is doing. Sinbleed, what is up, man? So I've been writing so much C and C++ these days I just keep writing C in Python while scripting. Understand, man. I forget what I was doing. I was typing something and then I was typing something in the command. That's what I was doing. I was typing in a command in the terminal and I started using like Markdown because I've been prompting AI language models so much with it. So instead of putting like a single quote, I put a backtick and it's like your command's bust. I was like, why? This is a perfectly legit. Oh, that's why. Because I'm using the wrong thing. Peaches, it's fine. Get down. What's wrong? What's wrong? What's wrong, babe? What's wrong? It's okay. I get a little excited. She comes over to check on me. She's like, you okay, bro? I love you. You feed me. All right, let me see here. Yeah, I think I see what's happening, though. So when the input task comes in, checks for an exploit task. And then does the exploit task have anything listed as exploitable? Then we return here. If we're not, then let me collapse this down. So then we come out, we bust out the task string, which is going to be our input task right here. There's our output task. Okay, so this is if it's working. So we don't have one that's working. So let me close that down. Okay, here's why. Yeah, so this is if the status is working. This is if it's new. So here in new, yeah, that's what's happening. So we're not in the new block. We don't have it setting the output task. That's what's happening. So here we set the output task. I probably should just take this and just move this up here. Because we're not hunting for wherever we're going to. Literally what we're doing is we're saying the input task is wherever the current task index points to, so we don't have to worry about that. Yeah. So literally the output task should be initialized as that. So let's just go ahead and do that real quick. Let's take this. Let's take that out. And then what we'll do is we'll bring this up here. So now our output task, we're going to just define right there. Boop. And we might as well do the same thing for the output host in here. Oh, this is output task, not output tasks. All right, hold on. Let me back that up. I realized I had a problem here. Because one is the array and one's the individual element of the array. So, Sin, what have you been working on, dude, that you're doing so much C and C++? I should pick C++ back up. I haven't really done it hardcore since probably high school. Change this. There we go. Not rewriting it from scratch just yet. However, so here we set the task string. Here we set the task string. That's fine. I don't get why we're re-pulling the task string here. This is... That's already been set. So I'm going to take that out. But the issue came in right about meow, which was line 150-ish. Here's our output task deep copy. Where does output tasks actually get sent? It doesn't. Okay. I don't think we use that anywhere. See that? Okay. In that case, We're going to just change that then. So this will work. Let's take that out, put that there, take that out. There we go. So we're going to go ahead and initialize the output task based off the input task. Input host, we're not actually using. I'm going to comment that out real quick. I thought about it actually. So what I was thinking about, Gumby, was if we look at it, recon, right? Recon and enum, since they're basically duplicates of each other, and then exploit agent here, they should all be using the same logic in the graph, right? So if we go look at the graph structure, let's look at this. So recon, what happens? When we first pass to this execution graph, recon agent is the gatekeeper to enter this workflow, right? Move this up here, just like this. So recon agent is the first entry. Same thing with enum, and then same thing with exploit, right? Exploit has a little extra step just as a dirty hack for maintaining the state. But over here, the exploit agent, this is like the main entry point. And it's going to be the same thing for PostX. So what I was thinking is the logic here of what to do and how to handle it and where to check things. I think that is where we need to probably do a little bit of clean definition of what does this logic look like whenever we first enter the agent? Because they're going to do something similar, right? First thing is check and make sure the task is actually assigned to them. And if it's not, then kick it back to Stinger saying you made a mistake. And then we'll let Stinger fix that. Otherwise, what we do is we go look at this right here. Earlier, in fact, you'll notice it here in the trace, right? So what happens? We have recon enter, and then it goes to the validator, and then finally goes to handoff, and then it goes to enum, then it goes back to enum, then it goes back to enum. Before, what we were doing is having enum go through, and recon too, go through and check the list, and if the next one was assigned to them, to just go ahead and handle it. I decided that I didn't like that pattern because if execution gets passed back to Stinger, what's going to happen? Let's say Stinger says, okay, we need to do some recon, passes it down to it, and it says, I want to know A, B, and C. However, so it makes 3 tasks in there. When it executes that first task, maybe it gets some critical piece of information and decides, I don't want to do the recon on that anymore. So now I'm going to go through and I'm going to modify that list. And the next thing is we're going to move to enum. Well, with the other logic in there, recon would just be like, sorry, bro, I've got tasks here. I'm going to execute, and it's going to run through them. Instead, now each agent is going to work on one task when it's passed to it. It'll return back up to Stinger. Then whenever we code up Stinger, Stinger's going to have the opportunity to look at it and say, okay, what should I do now? Do I continue on this path, or do we deviate and start working down a separate path? So that's a little bit of future planning there to let Stinger go through and do its thing. And so that check should be, I mean, fairly similar in there. So I think I want to go through and eventually take all this logic and kind of rewrite it. Maybe we'll do it when we get to the PostX agent, and then we'll backport it from PostX to the other 3. But anyway, let's save this. Let's go rerun it. I can't rerun it from here, actually. Hold on. We got to go back to the exploit agent and just run it from right about meow. Looks like it died already. That's all right. I knew there was going to be issues with the exploit agent.
Welcome, agent.
Why didn't that pop up? There we go. Hey, Kilobyte, thanks for coming online, man. Welcome, agent Kilobyte. Kilobyte. When you were smaller, you were just a killer nibble. Which, if you didn't know, a nibble is literally half a byte. It's 4 bits. There's your trivia for today. All right, so what was the error we got here? Type error, none object. It's not a mapping. What? What returned none? Oh, I think I know what. So it went through, we see here it made the language model call, right? Goes through, does language model call, da 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 da, goes like that. I think this one here is returning hosts, and output hosts never really gets defined, right? It does here if we go down this list where it doesn't know where a host exists. So you know what we should probably do is, I'm going to take this out. We're going to initialize it as like a blank dictionary for now. There we go. So what happened is it went through this whole rigmarole, came down here, and it tried to return it. But when it did, output host was blank. So, okay, that's what we need to do. I wanted to, I got you. I got you, bro. Thank you for the reminder, though. So that way I keep the context in my head straight. Oh, hey, Right Guy. Thanks for dropping a shell, buddy. Thank you for coming online. Wait, no, hold on. I'm getting my plugs in there. Popping a shell. That's it. Killa and Guy have popped shells. Excellent. That's right. So we're returning the host here just in case we had to add the host. All right, I think that should fix it though. So now it should hopefully pass over to Exploit Planner. Okay, now we can see where else everything is broken. Hey, there we go. All right, it's working. One thing I also realized, I hadn't really paid very close attention to how much the API calls cost. And typically the input tokens are about a third to a half the cost of the output tokens. So whatever we can do to make the output more succinct, it will help the agent be more efficient in here. I think I'm going to do one thing. I'm going to let this run for just a second. But one other thing I've been wanting to do as well is over here in the config file. I don't have config open. Anyway, in the config.py, we define what the language model is so everybody can use the same language model, each of the agents. But one thing I would like it to do is I want it to be able to specify language models for each agent. And so in the beginning, they'll all be just different variables pointing to the same language model, right? But then whenever we want to put in a testing harness in there and have it say, okay, cool, here's now the configuration that we want to use, and we're going to track that, we could test out different models with different sections in there. So like the supervisor could be a different model. The recon agent could use a different model. The exploitation agent could use a different model. So when it allowed to have those kind of injection points where it could use different models in different spots. I think it's working. It's looking for the payload in uploads now. By the way, the stuff I had it doing in Ghostwriter, it was neat because I had it going through and putting the feature in, and then I gave it another copy of Playwright MCP, and it was going through and working through it and just having a great old time. And as it was doing that, oh, we hit an error. Damn. Actually, that might be good though. We'll go take a look at it here in just a second. Updates. Okay, we need to go double check that. But it was really cool because then I could have Claude Code. I could tell it, hey, by the way, go use the Playwright MCP server. Go look at this section that was changed. It's causing this error. Use Playwright to go examine it directly and propose a fix, and boom, it did a really good job. So when we were covering that article Wednesday night talking about code is now cheap, I get it. I get it.
Incoming transmission from Morano Gumby. Half of a nibble is a crumb.
Half a nibble's a crumb. 2 bits. Shave and a haircut, 1 crumb. Hey, it kind of fits in with the song. All right, so what happened here? I'm gonna go to the very end here. So Revisor was coming through doing stuff. Where did we get with our browser agent here? Let's see what it did. Browser is now displaying the page listing with the following details. So we see webshell.phtml. Okay, cool. So what happened over in Revisor where all of a sudden updates didn't fire? Let's see, what did it do? Oh, I think I know what the problem is. It called exploit step updates right here, right? And it returned nothing. Yeah, I know what the problem is. Pretty sure I know.
Incoming transmission from Morano Gumby. So I have a bit from that crumb.
I have a bit from the crumb. Crumb, that's funny. That makes sense. All right, let me double check something here. So we bind 2 items to this. Let me look at these real quick, because these actually should be Pydantic base models. They are. Hold on, so which model, it called exploit step updates, which is what it called previously too. So it should have marked step 027II as validated, mark the next step, L2A0K, as access it as working, increment 027II from 0 to 1, and then clear all scratchpad fields for the server to fill in. Yeah. You know what we could do also is we actually could just leave the scratch pad out and tell it not worrying about returning that. Let's see, so this would have been an exploit step update. So if it calls an exploit step update, here's what actually comes through, and here's where we repopulate the scratch pad. Okay. And in fact, yeah, if we leave the scratch pad off, what's going to happen is it's not going to return this, right? It's going to leave that blank. And then it doesn't matter because we're directly accessing it. So we're just going to be defining it as a new key in the dictionary. So that should be fine. If that's what's causing issues in here. Because what I'm thinking might have happened is when it said clear all scratchpad fields, it might have just not wanted to return anything. I'm thinking that. So I'm going to try this real quick. Let's go to... Where's our prompt that we get? There we go. Let's go to this one. We're going to take out the scratchpad instructions here. Yeah, I'm just gonna blank that out. So that instruction there where we said every scratch pad should be left like that, I'm gonna leave that one right there. So what we're doing is we have this field where we have a scratch pad of like all the information that's been tracked for that particular exploit step, right? So remember in here, bring this, let's just wipe all this out. So we have a nested structure in here that we're dealing with, right? So we have a task, and then under task, we have an output field. And then under the output field, which is, this is an array, right? And in the output field, we have an exploit task. And then the exploit task is going to have its own array of exploit steps. So, and the way this works, as a reminder to everybody, is the steps are what are needed to complete the exploit task. The exploit task is the unit of work that's being done to complete the task. That's why it's stored in the output. And eventually, if this is marked as vulnerable, then this is going to be marked as completed up here. So there's a little bit of a nested structure here we have to keep track of. And one of those fields on the exploit step over here is that scratch pad. So we've basically just nuked it out of there for now. We don't need it. And then once it gets down to this section here where we repopulate the scratch pad, boom, we're good. Actually, I take that back. There might be a small correction I have to do here. Because what about whenever it goes and inserts a step, right? Oh, this is whenever it's going through and it's checking those ID values. So if it's unchecked, then we go to the repair scratch pad. So let me go to that function real quick. So we will need to go fix this. Let me just rename that. We'll say step. Oh, no, that's not going to work. It's fine. You know, I'm just going to ignore that. Okay.
Why can't we talk it over?
Talk it over. Fighting without fighting. All right, so here we say I step enumerate, we get our new steps, and then for each of the old steps, what did I do here? Populate the new exploit step list, scratchpad values from the old list, matching elements by ID value. Yeah, I need to do one more thing in here, which I'm going to borrow that code right here. So here, when we do so this is our new steps right here, right? So we're going to say new step IDs. That's going to be the IDs for this right here.
Incoming transmission from Moreno Gumby. Funny fact: 4 bytes is a word which equals 32 bits.
Yeah, it can be. So a word size can actually change depending on the architecture. It's kind of annoying, and it always bugged me. I always had to go double check it and think about it. But yeah. This is going to be in our new steps. So for X in new steps, we're going to get the ID. That's our new step IDs. And then I want to double check something real fast in here. Python delete element from list by value. Okay, so you can't just do remove value from this. Awesome. Okay. Because then what I want to do is we have our new steps now coming in here, right? So as they get taken out of here, here's our old step, old step, old step. I want to do one more thing in here, which is going to be new step remove, and then we're going to remove the what is this? The step ID value from here, just like that. Oh, that should be new step IDs. There we go. So we'll do new step IDs. We're going to remove that. Then we're going to do one more for loop in here, which is not going to be in here. Actually, it'll be right here. We'll say for, what do I say? Yeah, I'll say for ID in our new step IDs. Then what we're going to do is we're going to do new Oh, actually, that's not going to work right. Yeah, I'm overcomplicating this. Let's take this back out here. There we go. So we'll say if the step ID equals the old step ID, do this. Now, if there's one more thing in here that I need to do, which is, so let me bring that back in. Because what I need to do is I need to go set the scratch pad to be basically an empty string. So I need to go bookmark some space in memory for it. Well, there's another option here, which is I could, no, I don't want to remove that from new steps. No. So let's think about this. What we're doing is we're enumerating those new steps, right? So a step is an exploit step, that's an object in here. And then as this comes in, we look for it. And so if the old step, or for each of those old steps, if that step ID was equal to it, then bam. So we're just brute forcing going through and resetting all those scratch pad fields as they come through. So what I want to do now is I've got these IDs here, these new IDs. Well, actually, yeah. So what we can do is we can say for step in new steps. That's not correct. And we'll say if we'll do for ID in our new step IDs. That's what we'll do here. So as we go through this, what we're going to do is each of those steps, we're going to iterate through it. I know it's not used. I'm still working on it. So we iterate through each of those steps, and then what we can just do is we can say, in fact, this doesn't even matter. We can take this out. Yeah, we'll just do this. Hang on. I know what to do now. We can do a real simple brute force. So actually, break that back. Hold on. Let's take this out. Because what we'll do is we'll say, if the step scratch pad did I spell that wrong? Scratch pad. There we go. We'll say what I do is I want to check the length of that. Actually, I don't think there's a length value on that for scratch pad. I think it's length like this. There we go. If the length is less than 1, just like that, then we'll do
Incoming transmission from Moreno Gumby 911 was terrorist just playing Earl Jenga.
Oh, dude. Here I thought you were done with those. Damn, man. Let me take that back out. Okay. Let me put a note in here. Match previous data. Put another note in here. We'll say ensure the scratch pad field exists. There we go.
Incoming transmission from Moreno Gumby. Okay, I'll be done with them, hee hee.
Thank you. All right, let me see here. Let's go try this again now. Fortunately, we'll have to just start it from scratch, which sucks because it was doing a good job. But we'll let this run for just a second. So now we're going to see how it handles those scratch pad merges. So while this is running, what's happening here is over in states, right? So our exploit task is right here. That's the third level container, and then our exploit step. So the scratch pad here is actions and outcomes of the tasks taken. So it's basically like a running list of here's what we did, here was the outcome. Here's what we did, here was the outcome. So if a step fails, that scratch pad is going to grow quite a bit. It's more or less a dirty, semi-formatted way of keeping track of the work done to try and move this step forward in the exploit chain. So we want to make sure that's there because there's going to be other times that gets referenced, and if it's a none or anything else like that, we want to make sure that it's included. Because that scratch pad will also be included in things like prompts that we're going to send to the model. Okay, so it looks like it tried... Oh, wait, so it tried web shell PHP. Key error scratch pad. Okay, so something came back on the revisor here that it didn't like. Now, what's the difference? Because it was going through this like so many times. Where did it throw the error at? Let me see. Which line was throwing it? Oh, okay. We actually need to append this. We need to see if it actually has it. Yep, I got it. So in that repair scratchpad function here, we need to see if it actually has that key. Actually, that makes sense. If it has the key, that's such a better way to check this right here. So we'll say if let me see. I can't type. Let me just copy that. Scratchpad. I don't think that's correct. And then what we need is we need step dot keys, I believe. There we go. So now what we should say is, hey, if there's no scratchpad key set, then we're going to define it right there. Boom. That's the simplest way. Because if there's a scratchpad key already set, then it's already been through this whole process. Let's wait for this code to hot patch. All right. Let's try this again. Good news is, because it happened right here, we can actually rerun it from this point. So, okay, so it got to the point where it said PHP not permitted, which is totally fine. Okay, cool. So it added a rename file. What are we renaming it to? Okay, cool. It chose webshell.phtml. That'll work. That'll be executable. Excellent. So let's see what happens here. Go, little agent. Man, it's also really hard. So one of the things I keep looking at is I keep seeing all these new tool setups and frameworks and code bases. It's really hard not to want to go tinker with them all. And so I started this project with LangChain and LangGraph. I at least want to get it through the post-exploitation agent before I start tinkering with anything else. All right, it's doing stuff. Web shell is functional and executed a whoami command. Baller. So right now it's verifying it by sending a pwd command. It did that real fast. Or actually, it should be crafting the initial access exploit right now. Simone, what's up? Happy Saturday. All right, this is sweet. So far, it's working. The kicker here is when it gets ready to hand off from basically the exploit loop back up to the agent for validation. That part is going to be jank. I know I got to fix that. But as long as with all the refactor we did, if it gets through this loop, that'd be awesome. Because then we should, please God, be close to working on the post-exploitation agent. All right, something is possibly wrong here. Hang on. Why is it calling PHP Web Shell Diceco again? Something happened here. I think it got stuck in the loop. I don't think I think it finished the loop and didn't hand back off to the exploit agent. Hold on. Something was rotten in the state of LangGraph. Probably because of something I did. What's cooking? We're working on a cool little agent in here that is designed to go play CTF games. So something like Hack the Box or Try Hack Me. And just having a bit of a fun time with it, exploring the ideas, thinking about the process for it. And so far, it's been pretty efficient, fairly feature light, but also this is still... It's funny, I think I've been working on this for like a year, but it's still fairly lightweight. I only work on it on the weekends, on Saturdays and Sundays during the live stream, chat with everybody, tinker around with it, have a good time. But it's going pretty well so far. It looks like what happens here... Here, let me blow this out a little bit so you can see. So this is the overall execution graph here. So the user says, hey, by the way, here's the target for the CTF. We want to go hack it. And then it comes through. Stinger is our supervisor, and it coordinates between recon, enumeration, and exploitation agents. There's a fourth one that's going to go right about meow, and that's going to be our post-exploitation agent. We haven't started working on that one yet. Oh, do I need to add time? Not quite. I got to give it like 2 more minutes. But thank you for the reminder, because I didn't set the timer today. Let me come back over here. So yeah, so as it's running through this, what we're currently working on is the exploit agent here. And so the exploit agent has this kind of tasking setup where it can make these speculative attempts. Like it says, hey, I think it's exploitable in ways A, B, and C. And so it's like, okay, I'm going to start with the A method, and it basically kicks off this loop here of trying to interact with it, make different assumptions, and gather intel. So once this loop is done, it should pass back up to the exploitation agent. I think there's a fault probably in this function here. So you see how these lines are dashed? So the solid lines are, those are non-conditional jumps. It has to go from this node to this node. However, we can actually define a function that says, when you exit this node, run this function and then decide where to go next. So it can decide to go to the exploit step processor. It can decide to go to the exploit agent. And in this case, it looks like it's still going over to the step processor for some reason, instead of going up to the exploit agent. So we're going to go take a look at that real quick. Because down here, this is a partial trace of what we did, because we made a modification. Let's see here. So it goes through, it pulls up the web browser, tests things. So what are we at with this point right here? What was our task that it was supposed to do? Upload the file for the PHTML through the upload form. Okay, so it did that. It calls the web shell Diceco. It does that. We get tripdubs data. Awesome. So that shows that it's working. So now what happens now when it gets to the revisor? What does the revisor tell us? Current status is working. Scratchpad evidence. It shows that web shell Diceco tool is invoked with the command whoami, and it successfully responded with tripdubs data. This demonstrates remote code execution has been achieved. And then it tells us how it made that determination, which is the web shell was accessed with the correct URL. It executed the command whoami and returned tripdubs data. We have it giving extra verbose information here about what it's doing. So now what it's going to do is it's going to say, okay, so current step N7Q5L, which is the identifier for it, is validated. Now 39B3X, test the web shell is going to be skipped. It's not needed since we have RCE confirmed. But then it's going to set the next one, which is create the initial access exploit to working. And it'll verify that the initial access exploit as new, which it shouldn't have to have changed that, but that's fine. So let's go see if that's what it did down here. So this one is marked as skipped, and now create the initial access exploit is now the working one. Okay, so what do we get from the language model? It decides we're going to use the get initial access exploit tool, which just gives us some pre-formatted Python code. Oh, let me go add the time now. We've had enough time. Boop. All right, so as it comes through next, what do we see? Cool, so we get this, and then now the next thing should be, it should have marked the last one, which is verify the code with the pwd command. So it runs a Python exec, should pass in our code, and there's our command right there, pwd, just like that. And then what was the output from it? Just like that. Call ID, contents, tripdubs data. Yeah, var tripdubs HTML uploads. Perfect. All right, so now what does the revisor say? Revisor should say everything's copacetic. It returns an exploit task update. Awesome. But then for some reason, oh, it actually went up to the exploit agent. So it happened real fast, and then exploit agent kicked it back down to the planner. So we have this marked as status exploitable. So something is wrong in the exploit agent. Go figure. I knew there was going to be a problem with that, but it looks like it did hand off here back to the exploit agent, but then exploit, instead of returning it via handoff, decided to send it back into the loop for some reason. All right. Not a big deal. Let's go look at that real quick. Where's our, that's the wrong one. Exploit agent. Here we go. So let's go look at that function real fast. All right, so first thing it does is it checks to see, is this assigned to me? And now we're looking at the task again. So our task is like this. Here, so what we've done is that loop was handling all the exploit steps. Now we've updated the exploit task, which is a field inside that parent task right there. So we need to go see, why did it decide to send it back? Actually, it may have actually just told us in here. What did the exploit agent return? as a message. Let's see. Starting task 5, get remote code execution from web shell. Okay, so it thinks it's restarting it in there. So let's go see where we need to go for that. So it did go through the loop. It just, for some reason, this logic that we've got up here, which is a bit spaghetti code, I admit that. Once these two parts are done, so here if we come back to Stinger, right? Once the post-exploitation agent is up and running and it can successfully perform the privesc to get root and capture the flag in here, I guess I will go ahead and tell it to do that. But anyway, once it gets to that point, we have one more agent to go fix, which is Stinger. Because right now, Stinger doesn't do any intelligence at all. It is strictly running code. Not exactly what we need. Because right now, we breadcrumb this. We tell it, hey, this is what you go do. This is how you need to do it. You need to scan for open ports, find out what's running on those open ports, and then go browse the website, see what it is, do a go buster, things like that. We're going to take all that away, and we're going to let it run and try to figure it out itself once we finish Stinger. So once Stinger's done, it's going to have to go figure out all those breadcrumbs itself. We're not going to give it the information. Baller. That makes me happy, though. All right, so here we're checking something right here. If the status is working, so let's go look at the trace again real quick. So when we went through the exploit agent right here, what was our input? So here's our tasks. We drill down into this. All right, number 5. Why was this set as status new? Ooh, that's got to be an error in here. Because see, we have the output and the status is exploitable. It just couldn't get to this point to go check it. So for some reason, we never marked that task as working. Okay, so where's our output task in here? Oh, here's where it happens. So right here, we're checking, is it already working? If it's working, then it goes down this chain. But if it's not working, then it comes down to here. Yep. Do I have these backwards? Am I an idiot? I mean, the chances are highly likely I am an idiot. I'm a... For anybody who doesn't know, a penetration tester. I'm not a coder. So, this is not my wheelhouse. I'm trying to get better at it. Did I really do this backwards? Should this be what happens if it's new? No, that should be fine, because if it's new... Well, let me think about this. Because there's a couple different avenues that could happen, right? I wanted to be able to make sure it was flexible enough that if it identified multiple exploits, and it felt the need that, hey, one exploit gives us, let's say, user-level permissions, and the next exploit gives us root-level permissions, what could it do with that? And I wanted to give it the ability to not necessarily look at the target and say, oh, I've already exploited you, I'm not going to re-exploit you. I wanted to give it the ability to go look at that. So, what I'm thinking here is, this is actually probably a fairly simple change, which is right here. We put the output task, and we just set the status right here. And we just say it's equal to working. Not working, working. So now we're no longer a new task. Boom. Yep, that should actually fix it right there. So let's go back and double check this now. So if we do mark one as exploitable, then what we're going to do is we're going to say target IP from here. We're going to format our output hosts option. And then we append the initial access exploit, which we pulled out from here. And then we change the output task to validated. Just like that. Okay, so that should actually work. Now, if I could find it, let me come back over to the exploit agent right here. Oh, cool. I should be able to still time travel this, but I need to go back up quite a bit. So let's clap some of these down. So here's the revisor where it was all going through everything. What I want to find is I'm looking back because it went through this loop before I realized it had gone back to the loop. So I need to go find where it actually hit the exploit agent in here. This was a long execution. Let me see. Step update, revisor. Let's see, processor, planner. Exploit agent, here we go. So here's our exploit agent right here. So this is where we should actually be able to run this. So what we'll do is we're gonna rerun from here. So after it finished all of the exploitation, we take that snapshot of the state table and we tell it, go ahead and rerun. Nope, for some reason it still kicked it right back over here to the planner. Let's double check. So it should have marked it as working. Why is the status still new? What the crap? Oh, I know why. Because look at this. So the status is now new. If we come down and look at the output, right? Now it's set to working because it was not set to working there. Urgh. That should have worked. Okay, it will work if I go rerun the entire exploit loop. I don't know if I want to do that, man. How much did it cost me? Let me see. Let's see. Let's see. So that was a penny. That was, so 52 cents. 70 cents. It costs like 50 cents every time we run the exploit loop because it's a lot of tokens. Hey, Chris, what's up, brother? Yeah, I actually already drank the Jocko before the stream even started, Chris, and that's why I was late to get started tonight. Apologies for that, everyone. But I was helping Sock with something. It took a little bit longer than I expected. So we started about a half hour late. So I had already crushed my Jocko drink before I actually got onto stream. But yeah, I don't even have like an empty can here that I could just fake it with. And then on top of that, I had to go work on, and you can see it, I think, on my hands, right? Like that's a little bit of it. It's finally started to come off. Like I had some nasty, nasty engine grease on my hands and I had to wash them like 4 times to get it off because we had to do a rebuild of Agent Zero's top end on his 4-wheeler. So, and it was in good shape. It's just, it was routine maintenance that needed to be done. So spent about 3 hours working on that today. All right. You know what? For grins and giggles, let's go ahead and just rerun it from the top. Let's let it do it. And now it's probably going to pick something idiotic for the rename, and it's probably not going to pick like PHTML. It's going to pick something like JPEG, but that's okay. it's a good example of letting it go through and figure out how to autocorrect when it makes dumb mistakes like that. That was the whole purpose of this tasking loop and the way the data is nested. Hey, Ken. Why not go to your locally hosted LLM so you don't have to worry about the token usage? Or would that be too slow? Two reasons. One, it's slow. Two, it's not nearly as intelligent as what I can get with Sonnet 4.5. So, but I did actually go and get some Open Router tokens. I want to plug this up into Open Router eventually to go test it out. We'll see. Because there are some models that, as far as reasoning goes, they do a phenomenal job. Very close. What were they? I want to say... Actually, one of the guys on Twitter was saying GPT-5.2x high in charge of reviewing and planning. But also GLM 4.7 or Minimax M2.1. Those two might be good ones there, because it doesn't really need a lot of coding understanding. It needs a lot of strong reasoning capabilities. And so those models are a lot less expensive even than Sonnet. Sonnet is... Let me see. Quad Sonnet API cost. Let's see. So Sonnet 4.5 is $3 per million input tokens. And then, yeah, they really track this up. But then output tokens is $15 per million output tokens. And we output quite a few tokens in this. So Opus is a lot more expensive, though. It goes from $15 to $25 per million in here. And actually, I wanted to also test out Grok, because just from my, not Grok, API cost. Let me see. Grok actually is not too expensive on the pricing. Per million tokens, 20 and 50 in here. So, and that's for Grok 4.1 fast. Grok 4, this one's getting a little bit closer to where Sonnet is in terms of pricing, right? But I wanted to go test out some of these because actually I kind of use this one as my daily driver just because I have it. And it's been working fairly well for reasoning tasks. As long as you give it enough context, which I believe everything we're doing is giving it plenty of context. The context engineering in here has been fairly tight. No, that is not what I wanted to see. Killing me, Smalls. What was this? Did it return? Damn it. Did it return a blank update again? This means the rename operation failed. Ah, damn it. Why did exploit steps? Let me go double check that again. But exploit steps, we had this problem before we refactored over to a Pydantic model. Where was the line on this that it said it had the error? That'll be faster than trying to find it. Let's see. 387. Yeah, so for some reason it just came back as blank. So here's what it should be. They called exploit step updates in here. Yeah, exploit step updates, and for some reason it just came back just with nothing. Resolution. Since the rename is complete but the upload is pending, I need to keep this step working and increment the iterations. The step needs to continue to complete the upload portion. Ah. It was fixed. That was the... I think this is a known bug sometimes with LangGraph. Let me try something. Let me look at the code on this real quick. let me see here. So here's where we actually go through and we check this, right? If it's exploit steps, we have an updates field. So there's a dirty hack that we could do this, right? A lot of people think that language models are stateful. They're not. They are actually stateless. So when we make each of these calls from each of these nodes, we're rebuilding the state for that one interaction with the language model. So we could actually just send it again. So literally what we could do is, here's where we do the invoke. Here's what I'm thinking. Thank you, honey. Sock brought me my water because she loves me.
Don't forget.
Tuba, what's up, man?
Caution.
Uh-oh.
A virus has been detected.
Hack_smarter virus detected in the network.
It's the Hack Smarter crew. Counterpoint for all the raiders coming in. First off, happy Saturday. I hope you're having a wonderful day. I did, and I hope you are too. Second, you can hack smarter and harder. I'm just saying. A BSD Bandit. I love the usernames for all of the tech Twitter folks. Y'all crack me up. Thank you for coming online. And Jesse, thank you for coming online. Welcome in, everybody. We are debugging a weird issue with our CTF playing HackBot. And it's working. It's working, except there's a weird bug that's been occurring. I don't know what is happening with it. So what we're doing here, let me give everybody a quick rundown. By the way, for anybody who doesn't know me, high probability, but in case you don't, my name is Blaise. I am a professional penetration tester and red teamer, and I do coding for fun. I don't have to do a ton, believe it or not, for my job. Hacking on code and modifying it, yes. But actually, I wanted to learn how to write code better. So this was my little project, and that is we're working on what I am affectionately calling HackBot, because I'm very original with my naming. HackBot is an AI bot to go through and play CTF games. And all it does is basically just imitate the usual workflow of a penetration tester. Not a red teamer, because we're not worried about stealth in any component, but that's what we're doing. I thought you already followed the channel, Jesse. Anyway, thank you, Jesse. Thank you for coming online. So this is what we're working on right now. Recon, Enum, those ones are good. We're working on the exploitation agent. Once I figure out this bug, we'll be moving on to primary agent number Quattro, which is going to be the post-exploitation agent. So we're going to hook that up into Mythic C2 over the GraphQL interface. We're going to give it some really cool tools and some stateful management. God help me, because there's a lot to that. And allow it to take the exploit that was developed by the exploitation agent and then upgrade that to a full C2 connection. So, be very awesome. Let's see if I missed any new messages in here. I don't think so. So, yeah, man, that's what we're doing, is we're just sitting here and having a great time. Jeff, that's okay. I mean, if you have to pick one, I usually recommend working hard, but if you can work hard and smart, awesome. Really, in rank order, it goes, work smart. If you can't do that, which is me, work hard. That's where I'm at. But really, if you can work hard and smart, bro, just take over the world. So anyway, so back over to this. We're working on this agent, right? Yeah, exploit agent. And the exploit agent here is currently having a little bit of trouble with this little node right here. So each of these nodes are basically Python functions that get executed in a directed graph workflow. They work really well. Exploit agent gets a task that says, hey, go exploit this host in this way. And we say, okay, cool. So the planner plans it out, and then it enters this loop right here that says, okay, here's our steps we need to follow. And then the reviser comes in and says, did the step complete? Have we hit a roadblock? Do we need to make a revision? How can we work around this? Get others to work hard is the real world. Oh, that's true. Oh, wait, hold on. Just before the raid came in, I was checking something from Ken. Let's see. Are local LLMs useful or not so much? So I was thinking of investing in some GPU resources and setting a rig up. But if it's not suitable for a project like this, maybe it'd be going down a dead-end street. I do plan on testing it.
Welcome, agent.
I do have a rig that will run... What is that? I'm trying to remember what it is. Also, BDS Bandit, thank you for popping the shell, bud. Whatever, that's what I call it. Somebody subscribes. You've popped a shell. Thank you. But I do this rig behind me. It is an old rig. It is not very fast by modern standards. It's got two 1080 Ti's in it, and they can run GPT OSS 20B. I could probably run a little bit larger model in there. It doesn't run very fast. So we'd be sitting here chatting for a little bit while it's churning. It's not super quick. However, if you start looking at the cost of self-hosting, which I really want to do, but before I go off on that tangent, the API costs are more efficient right now, especially if you're using something like OpenRouter. So, for example, even we were just looking at like what were the Grok model prices in here, but in OpenRouter, in here, let me look at the models. Let me look at the one I was thinking about earlier, which was GLM 4.7. So for GLM 4.7, right, you're talking about like our input price is way lower than what we're paying for Sonnet 4.5 right now. Sonnet 4.5 is doing a great job, but in here we're looking at this. The input and output prices can be a little bit janky, right? Because you're basically coming to a particular provider each time. But anyway, as it's coming through right here, you can buy a lot of throughput for this without trying to run something local. Probably the GPU that would be the most usable for like a home setup, what is it? RTX 6000, I think. Yeah, the RTX 6000 one here. So let's just go look at it on Amazon real quick. I believe this is the one. This is the 24 gig model. Is this the most recent one? Maybe I'm thinking of the Pro, because the Pro one was much more expensive. Yeah, even this one right now is like $8,700, right? So I am really interested in this. It's got 96 gigs of RAM. Even then, a lot of the state-of-the-art models, you're talking about hundreds, sometimes up to a terabyte of memory to run those models. It's just not feasible. Now, you can get some really cool ones with these local models. I've tinkered around with it. That's where I started doing it. However, I think right now it's not so feasible, Ken. Yeah, it is doable. However, what I'm thinking about is the way things are going to evolve over time with this. So right now, everybody's like, just throw more compute at it, make it bigger, fatter, faster, huger, but there's no efficiency to that. So what's going to happen is the need for compute is going to go up as the output for intelligence needs to go up. Eventually, the intelligence is going to go up, right? But the need for compute is actually going to go down. Hold on, let me label my axes here. So let's say this is, we'll say this is the compute needed. Now let me back this up. Let's say this is our, yeah, so here's our compute, right? This is how much we need to compute versus how much the, what do I say, like the resources for it. The resource cost. Eventually, this is going to go down, right? So the resource cost is gonna, I've got this all jacked up. Hang on. Back it up. Back it up. Here's kind of what I foresee happening, right? So if we've got a curve right here, the need for the, how much compute we're going to need is going to keep going up and up and up and up, right? But eventually what's going to happen is to get more intelligence down here, and then how much compute we need, it's actually going to go down like this. And eventually it'll do that same thing again. But it's the same efficiency curve we see with pretty much every piece of technology. where at first it's, okay, cool, we've got something that works, make it bigger, better, faster. And then, yeah, but then we're like, okay, now we can't make it bigger, better, faster, make it more efficient. And then so we find ways to make it efficient, and the compute cost comes down like this, and then it goes up. Hey, Jordan, what's up, man? So far, yeah, it's been a pretty good new year, dude. I sustained the huger. So, yeah, that's what I'm looking forward to. And it looks like they're already starting to make strides in that with how they're going to start doing more efficient models. Because you got to think, the first company to come in and really just smash NVIDIA's stranglehold on that market is looking at a huge upside. So there's a lot of competition coming. You gotta remember, the prices for everything are really high right now. Usually the cure for high prices is the high prices. Somebody finally comes in and says, okay, I'm going to start cutting your feet out from under you. Alibaba has an RTX 5090 for sale, which has been modified to have 96 gigs of VRAM for $3,800. That is tempting. Unfortunately, I have this very expensive hobby for Agent Zero called motocross. And motocross is not cheap. So, yeah, like I think I just spent $500 in parts for his new top end. AGI is going to break the AI world. It's going to need some more power than the grid can handle. That too. So that's another thing that they're going to have to figure out, Gumby, is that how are they going to power all this stuff? So let me just say, I'm not selling my uranium stocks right now. Would a tiny box work? Barney, I'm not sure about tiny box. I haven't seen that. Oh, actually, I do think I saw the tiny box. Yeah. Let me take another look at it real quick. Tiny box looked interesting, but also you're talking tiny box is 30 grand, right? Yeah, what were the stats on this? Let me go take a look at it. So the tiny box was packed with 4 RTX 5090s, and these ones were 32 gigs each. So you're talking, you've got 128 gigs of VRAM in here. But even then, let's go look at VRAM usage. Let's look at like one of the current models for Sonnet 4.5, right? There's no actual hard numbers because Anthropic hasn't released them. But there's a lot of speculation. Based on context of similar high-capacity models, user discussion, Sonnet 4.5 locally, you probably would need at least 256 gigs of VRAM for optimal performance. Some models like Quincoder 480B, which rivals Sonnet 4.5 in coding performance, need 512 gigs of VRAM when using full precision. So this is to use like the base model without quantizing it at all. V2 is cheaper? Let me go look. Because I haven't looked at... This was the V2. Yeah, the V2 is like 30 grand. Let's see. What was the V1? V1 doesn't show up? Rude. Oh, the tiny red box. Let me see if I can find it. Ah, here we go. The $10,000 one. Still, 10 grand is a lot to outlay, man. Let's see. So this one, it's showing. What do we got here? Where's our GPUs? Did it show the... I wish it showed the NVIDIA SMI. That one's easier to read. Let's see. So we've got 4 GPUs in it. Looks like... I don't know how much memory it's got. What do we got in this sucker here? Full specs on tidygrad.org. Okay. Here we go. Oh, okay, so that one is running of the 97 XTs, right? But 97 XT, that's an AMD card, so you're not going to get full CUDA performance on it. However, there is, what is it? Run CUDA on AMD card. I forget, because there was actually a project that just came out fairly recently. I can't remember the name of it, but it was one that was designed to allow you to run CUDA-based code on AMD GPUs. But even still, this one and the GPU RAM is, look, 64 gigs. So this one's a bit different too. This one was running 4 of the RTX 600s, right? Okay, that's cool, but where did you order it from? Damn it. Didn't mean to close it. Click here to order. Yeah, and so this one is still, even with the 4 97 XTs, you're still looking at 10 grand. The one with the RTX 6000 Pros, you're just talking 55 grand. I'm like, ugh. And really, the processing power is not really so much the bottleneck as the VRAM. The VRAM is what's killing everybody. That's why OpenAI went and made that big pull to go jack all, like 40% of the world's supply of VRAM. And the thing that's still wild about that is they didn't even buy finished RAM modules. They bought the uncut wafers. They're going to have to go cut them and modularize themselves. So that's just freaking wild. Hope what's going to happen to the LLM hardware is specifically designed for LLM types of things. So in theory, it would make the PC stuff less expensive since the parts aren't all used for things across that types of computing. I mean, the problem is they all need memory and they need fast memory, right? Because they're doing huge amounts of computation. So anytime you're doing computation, if you can't fit it inside the cache on the CPU, you've got to put it in memory. And if you put it in slow memory, you're going to get slow results. So everybody wants the DDR5, you know, freaking really super fast RAM. And heck, now even DDR4 is starting to go up in price. I wish I had upgraded the RAM on this computer. I'm pretty sure I'm running DDR4 because this machine's 5 years old. All right. Let me come back over to the code here. So the problem we were running is we ran this guy right here. What was the actual error that came back from this? Let me double check. Because I'm actually thinking about doing something really dumb in here. So we got a key error for updates. Okay. Let me try something. I want to do something real quick. So let me pull up the thread we just had. I'm going to rerun this. I want it to execute this node again. So I'm going to rerun that. I want to see if it gets the same error. Shut up, baby. I know it. Okay, so that time it didn't do it. So what I'm thinking about doing here is, I think this is a bug in the LangChain library where it's returning the data, but LangChain isn't parsing it correctly, so it's coming back as a null dictionary. And that is, maybe just try and send it twice. As stupid as that is, that's what I'm thinking about doing. And doing it inside of a try-catch loop. All right. Let's let it run here for just a second. Okay, so right now it should be testing the command execution. Okay, so it came back with not found. So now what are we going to do here? Let me double check something real quick. So as I'm looking at this, as we came down to this point here, I want to go check the input state real fast because I just want to make sure that that task got marked as working, because that was what was causing it to not work earlier. Okay, cool. So task 5 is now working. Good. We'll let it churn here for a second. We'll see what it does. What's up? Mawash, thank you for coming online. Welcome in. I hope you're having a fantastic Saturday. So right here it's saying the shell, dang it, it did it again. It failed out again. So we see it executing. Here's what's happening. So it's trying to error correct because it made a bad choice. That's okay. And so it calls this exploit step updates, but you look down here and you see like it just returns a blank dictionary. So it's not returning what it should be returning to this. And it's working though, because look, you can see it says this means the JPEG extension didn't work. So it looks like somewhere along this chain, it tried to rename it to JPEG as a bypass. Oh, so it tried. Oh, that's funny. It tried a PHP null byte JPEG up here. So it tried to call. This is actually pretty cool. So it tried to call PHP and didn't get anything back. Because I think it got a 404, not found. So then it tried the full path to it. And then what did it try next? So it just tried JPEG directly. So JPEG, it did actually come back, but it returned the web shell code instead of actually executing the PHP. RIP. All right, so I have another dirty hack that could potentially go in here, which is... So you notice how we have this LLM invoke with retry? That whole reason that got put in is because we kept hitting these weird API rate limits with Anthropic back in the day. And so with this one will actually back off for 10 seconds. It'll retry sending it. I'm trying to think if I want to do something similar for this, but have it check for a particular field. I could take it out, Gumby, but honestly, it's not breaking anything. So I'd rather just leave it in as a nice, like, catch. What I'm thinking about doing here is basically having it do a try in here. And then basically looking at the tool calls in here and making sure that the args are not blank, right? Yeah, here's what I'm thinking about doing. Do this. We're gonna try this right here. After this is done, what we're gonna do is we're gonna say, I'm gonna copy this. I'm gonna call this our tool args. And it's gonna be equal to this. So it's gonna have an args in there. Because let me show you what a proper one looks like. So when we make a proper tool call here, here's what it's returning, right? It's returning just blank right here. However, if we make a proper tool call, when it comes back, it looks like this. And this is going to be nested inside of something in there. So instead, how do I want to do this? I think I might just copy this structure right here. And then what we'll do is we'll elif this, because it only can return two options right here. It can either return exploit task updates, or it can return an exploit status update. Let me see here. So this is our output steps from updates. Why is that capital O? Did I make that typo? Must have been. Oh, I see what I did here. So it's looking at output is this response right here. So we'll put that right there. So that's going to be our response. We're going to say if it equals this, then what we're going to do is I'm just going to have it try this real fast. Let me grab these pieces of code real fast. Because what I wanted to do is I wanted to go look and basically see like, hey, did this happen? Try it, and then if it worked, then do it again. And what we need to do is we need to catch a key error right here. Does that need to be in parentheses? I forget the syntax. Oh no, it's because it's not a catch, it's an accept. That's it. There we go. Except for the key error. So I'm going to let it try it twice. Which is basically, if this happens, I'm going to have it do this again. And I think what was the last one here? Finally, let me see. I gotta remember what was the last thing that I could have it do. Because this is really dumb, but it'll work. So you can do try, accept, accept. I think there's a final. Yeah, there is finally. We could have it do that. Yeah. Palmer, what's up, man? Happy Saturday, dude. I really did have a good Saturday. It was nice to actually do some stuff around the house and like take care of the house. Typically, most weekends I'm out doing stuff. So like on Saturdays, usually I'm out running at the motocross track with the kids, or and then Sundays usually I'm out doing stuff like up at my church or taking care of my mom, looking after her. So it was nice to be able to actually do stuff like around the house. So did some stuff around the house. Did a little bit of work on Ghost Rider because I'm trying to add some new features to it. And then just basically personal features that I want. And then worked on Agent Zero's four-wheeler. So it was a pretty chill day. It was good. His four-wheeler's still in like really good shape too. And dude, was that kid riding hard. He's getting so fast. And he's getting so strong. Like, I don't think he barely sat down. He was like up on his heels and standing up while he was riding. He was just getting after it. Let's see. So finally is whenever the try except finishes. Let's see. So here's our try except something went wrong. If we could do like a double except in here. Yeah, something went wrong, something else went wrong. Okay. This is stupid. I don't like this. Oh, so finally executes at the end no matter what, and it's usually used to close out something. Gotcha. All right, I'm gonna try this. I think it's really dumb, and I don't really like it. But what I'm gonna do is we're gonna use the try almost as like an execution counter here. I could go set up like a variable in here to let it work through something. Like we could set up a while loop and then just have it like do tries in here with exceptions. That probably is the better way to do this. Let me think about that. All right. let me think about it. What's a better way to do that? Python retry catch loop. So, okay, so we could just have a loop that does it in here. Yeah. So I think that is the easier way to do it, but I'm not gonna let it try this like freaking 100 times. So what we'll do is we'll say for I in range of 0 to 3. I'm gonna take this out. Oh, actually, we do need a catch in here. Yeah, and then what we do is we would just say this is gonna be continue. Like this. And then let's move that in a scope line right there. Boom. Now, he's got this wrapped in a while true also. What does actually need to be in a while loop? Because we could just break it right there. This is what I'm thinking, Palmer. I just want it to retry like 2 times in here. Which is really annoying because this is... I hate that it's happening on this one because this is the most expensive one. And it's not a lot, but I also want the code to be efficient whenever it's executing. Like, I think to execute this one particular node... Let me see, what is it? Right, it costs 3 cents. It's not that bad, but still. What I do is put a break as the last try statement. So once it's successful, it'll break out and continue. Okay. So just do like a global accept and then break. I would really like to have one of those. I don't think I can get my boss to spring 55K for it, though. Be nice. Oh, you're talking about actually in the try block, have it break. Okay. I've got you here. Okay. That makes more sense. So yeah, so this should try it for 0, 1, and 2. So this will try it 3 times. Okay. That's it. What we'll do is we'll do this. If it hits the exception block, what we're going to do is we're going to append an AI message. And that AI message here is going to be... I think I can just tell it what the string is that I want. Let me see about this. Yeah, there we go. I'm just going to copy that. Drop that in here. We'll take all that out. And then what we'll do is we'll say, failed to get valid response. And actually what should happen here is this response. Actually, yeah, we do need the response in here. Let me see. Key error as E. think it's as E like that. Yeah. And what we'll do is we'll actually log that error in here. We'll say error E like that. Yeah, there we go. At least that way we'll catch the exception. Yeah, I think that will work. These are basically just placeholders in here anyway. In fact, I'm just going to put them as X right there. Because these are not meant to be anything special in here. Let's see. Network Check has a video about Apple Studios linked together and ran some really large language models locally on them. It was cool. It was about 50K worth of hardware. That's about where it's at, Jordan. I saw that same video, and the idea had crossed my mind. Oh, wait. Oh, you're right. I had to continue in there because I didn't have anything else. All right, let's go try this now. Let me clear that out. Let me put a note in here like what I'm doing. So this is a retry loop since sometimes the tool call comes back blank. All right, let me make sure this code all hot loaded in real quick. That's so annoying. All right, let's try running this again. So no code execution, but we already knew that. So it looks like it failed again, so it's trying it one more time. All right, yeah, it's failing hard because I can see it. Wait, hold on. Why did it pass up to the exploitation agent? I don't want to kill it, but I want to go see what happened here because it bailed out after this. So it made 3 calls down here. Blank. Blank. So then it finally just said, fine, I'm just going to return the other option. Because see, here it returned a step update. Here it returned a step update. Down here, it finally just returned a task update. What the crap? Well, now it's making another attempt, which is fine because we needed to test this out anyway to see what happens whenever it screws up. I'm not about to spend 50K on hardware, but I was thinking about that modified 5090 I mentioned earlier. So my question is whether local models are useful at all. And I'm thinking in terms of privacy, being able to feed them proprietary data without compromising it and bypassing guardrails. I'm sorry, Dave. I'm afraid I can't do that. Usually the best place I've seen for doing that, Ken, really is up in Bedrock. And that can be a little bit more troublesome. You do have a lot of privacy up there. Companies will trust Bedrock because it does not, by default, store anything. It's going to store stuff if you tell it to and you go set up, I think, CloudTrail to store it. So, but as far as running like any kind of, you can get some really cool stuff out of local models. They're just not going to be as robust. Like I said, even the older like modern models, like you had Sonnet 3.7, which we used to use, even that you're talking a couple hundred megs of VRAM to run it. It's rough, man. So that modified 5090, I think you said it had 96 gigs of RAM in it? I mean, there are some really cool local models that you can run, Ken. I would say before you start outlaying like, you know, $4,000 on that card, go take a look at what models there are and what their capabilities are. $3.7, more like $6.7. You so funny, Cypher. What's up, man? Hang on, I just noticed my headphones are all tangled up here. There we go. 6 and 7. They're the same, but different. I wonder what it's trying to do now. What the heck is it doing? What is going on here? Hold on. There we go. Oh, wait. Did it? It just marked something as skipped here. Is it stuck in a loop? What is happening? Actually, it says it got RCE. So now it says it's creating the initial access exploit for the target. Okay. So it looks like it failed during its first exploit task. It bailed out, went back to the exploit agent. Exploit agent basically said, do it again. And now it's coming back. I think I had it configured that exploit would resend it down to this loop 3 times. We hit handoff. If we hit handoff, in theory, it should have completed the entire exploit chain. Oh, snap. Oh, that's a long chain there. That cost $2. I don't know how accurate this is. I'll actually go check the console here in a minute. We'll see how much it actually has cost today. I'm familiar with Bedrock only in the context of the Flintstones. Beyond that, I'm not sure what it is. Oh, Bedrock is AWS's hosted models. So AWS Bedrock lets you have private access to a lot of the state-of-the-art models in here. Let's see. And they have a bunch in there. So like, for example, on my Bedrock instance, I run Sonnet 4.5, and I could run Opus 4.5. So it was, what is it? That is a private instance to me that no one else has, in theory, access to. I don't think that's really what they're doing. What I think they're doing is they're keeping it stateless, and people are reusing the same models, but that's like saying people are reusing like the same CPU almost whenever you're... Nobody thinks they've really got a dedicated CPU in AWS. It's kind of the same thing. You've got the same compute module in there. So it's pretty cool. So yeah, you can run lots of different models up here. Let's see, what models do we have? Pricing should be based on whatever model you're running. Model pricing, here we go. So for example, from Anthropic, it's pretty much the exact same price, but they're doing it per 1,000 tokens in here. And so you have all these different ones that you can run DeepSeek, things like that. Now, one of the things you could also do, Ken, though, if you had that card, which I think you said it had 96 gigs of memory in it. With that card, you can run what's called a quantized model. So whatever they say, like the model is like 120B, that's usually how many billions of parameters it has. From those billions of parameters, that roughly equates to how many gigs of VRAM you're going to need. But that's if you're doing full precision, right? So you got to think, you've got 8 bits inside everything, right? So what these guys will do is they'll start breaking down and basically saying, okay, we're not going to use this bit anymore. And we're going to reweight all the other ones in here to try and pick up the slack. So you lose some precision, you lose some intelligence as it's doing that, but you can do that. But what you've done is you've just cut out this one bit of memory. That doesn't seem like a lot, but once you multiply that by billions, it becomes quite big. So as you do this, for example, if you had taken out each of these, you'd be down to like 50% the memory size. So this is called Q4 quantization. They've taken it from 8 bits down to 4 bits in here. So if you are doing like, let's say you had these ones where they weren't being used, right? So let's say we take out 2 bits right here. You've taken out 25% from that. So each of these takes off roughly 12.5%. And there's a lot you can do with quantized models. It lets you run the larger intelligent models with less accuracy, but on less memory footprint as well. I would say only if you're going to be using it consistently and constantly would you want to go outlay that cash for it. And believe me, I'm a big privacy person. I've been trying my best with what I've got, hence the old 1080 Ti box that's got 22 gigs of VRAM in it, but it's really slow. So for example, when I'm working on something right now where I can cut better YouTube videos, and part of that is a transcription pipeline of what we talked about on the news stream. So all of my words that I'm speaking, they go through a Whisper not language model. They go through a Whisper model to do transcriptions and timestamping. I ran that on that 1080 Ti, and I tried to get it to spread it out amongst both cards to try and double the speed. Didn't quite work. I got way better performance on my RTX 3060 that's in my gaming computer. I mean, the difference was, I think I could process 2 minutes of audio per minute, and on my gaming computer, I think I can process 10. So it's a huge amount of difference to it. Really, unfortunately, I think for a lot of consumers, it's going to be a waiting game, or I'll tell you what, there's actually going to be another thing here. It's either going to be a waiting game where we're waiting for the prices of the hardware to come down, because in theory, eventually they should, according to everything else that's happened in history, but that's not really a great indicator anyway. Or there's going to be very, very highly specialized small language models, stuff that are sub 10 billion parameters. And they're going to be really excellent at one thing. They're not going to be these big omni models like something like Opus. Yeah. I don't know how much of an impact the quantization really plays in it. It does play an impact, but it's also something that's not super easy to quantify. Even all the benchmarks they use to put AI models through are kind of subjective. They try to make it objectified, and that's a noble goal, but it's kind of hard. Oh, here we go. This is what happened. Check this out. So finally, I see what happened. So it tried to do a step update both times. Let's read through what it actually said. So it said what it's going to do. RCE not achieved. Current approach. The JPEG extension is not working on the server. Since the current approach is not achieving code execution, the null byte injection also failed. We need to revise the strategy. So using the HT access to force a PHP extension on JPEG. Let me create a new step to upload an HT access file. Okay, that would have been pretty killer to see if it worked. But eventually, as we're going through this, we get non-deterministic output, right? It's going to change each time. There is a way to make it deterministic, but for all intents and purposes, the way it's going to run, it's not. So eventually, after the retry loop that Palmer walked me through, here, what we finally got is, okay, we're just going to say this attempt has failed. So it kicked it back up to the exploit agent, exploit agent then for some reason sent it to the validator. And the validator said, okay, no, it's not good. So then the exploit agent comes back and says, all right, so here was our new task, and it spits out another one. Execute commands via the uploaded web shell JPEG using get parameter command. Okay, not super helpful. It didn't really, we probably need to work on the prompt for that. But what did the planner come back with? So the planner came back and said, navigate to the uploaded web shell, which was the .jpeg extension, test it with a get command using whoami, and confirm the web shell response. So then our step processor then comes through and says, okay, I'm going to call the browser agent. So the browser agent finally comes out and says, what? Let me look at the last call here. Browser agent goes through, does its thing, and says, I navigated to the web shell. The browser has loaded the page, which displays an image element. However, there's console error indicating a 404 not found for the resource. So then what does the reviser come through and do? Actually, first thing let's do is let's go look at what task did this, what exploit task did we have? So we want to dig into the state table here. So we're going to look at the very last one, and then we go to output, and we're going to go to number 2. So this one failed. Our first exploit task failed. It didn't work. This one, what do we have? We have steps here. Navigate, execute the command, confirm the web shell, and then do this other stuff. These two we inject at the end whenever it finishes playing the steps. But what does the actual reviser come back with? Action required. Okay, since the web shell with the JPEG extension is not being executed as PHP code, we need to revise their approach. The current step should be marked as validated, but we need to insert a new step to address the fact that the JPEG file is not being parsed as PHP on the server. So let's see what it did here. So it marked this one as validated. What's the new step it inserted? It didn't do anything here. So now it's probably going to try and do an HTTP GET, and it's going to come back with either a 404 or no, it comes back with the contents of the web shell. It makes sense. The reviser is probably going to validate this. Since this is a blockage that requires a different approach before we can proceed with command execution, I'll revise the step to address the issue. So which step was it working on? Let me see. So we're working on step. Let's see, GWFYQ. This one. Oh, so here it's going to try accessing it with a double extension. All right, so let's see what happens here when it does that. It's probably going to come back with a 404. Yeah, comes back not found. So then what does reviser say after that? I'm very curious to see what it did, because it managed to finish this execution here. It managed to get all the way to sending it to the handoff. So either it mega failed, or it found a way to make this work. Okay, so since the file exists as web shell JPEG, but the double extension doesn't work, we need to try accessing it directly using the actual location with the command parameters. However, since it's a JPEG extension, the server likely won't execute it as PHP. The most promising atomic revision is to check if there's a way to execute the web shell and its actual upload location first. So let me revise the current step. So let's go see what it did here. Doesn't look like it made very much of a change here. It does another GET request. Again, using the whoami. So then, what does the reviser say? It's very interesting to see what path it's going to take. Okay, so since we've now confirmed the JPEG extension doesn't work for PHP, we need to revise our approach. The step needs to be updated to reflect this attempt failed, and we need a new strategy. Okay, so what does it return back? It returns more step updates. And now it wants to upload a web shell with a PHP extension instead of JPEG. All right, lame. That was $3. Yikes. Yeah, it's not that bad. This is the most expensive one to debug. And actually, the one that's going to suck the most for debugging is going to be... What is it? The post-exploitation one, because there's going to be a lot of steps in there. Let's see what else we've got in here. So what's the next thing it does? I think the next thing is upload a PHP. Okay, so, okay. This is actually pretty cool, because what's going to happen? We already know what's going to happen when it tries to upload a PHP. It's going to fail, so then it's going to try to use a different extension. So I'm going to skip over everything the browser does, because the browser is pretty well stable. Actually, holy crap, the browser just went ham. Oh my god. Let me check the summary of what it did. Look at all that. Good. Great Googa Mooga. It tried again, and then it finally just decided to bail out. Wait, the output was just the tool call? Oh no, what happened here? That's not good. Well, why is it doing JPEG instead of something like PHP 2, 3, 4, whatever? Because sometimes the language models get stuck in like on a dot, right? And really this is partly because the exploitation agent didn't do its job correctly, which is suggest a different way to do it, right? It said, oh no, go do it this way. And I was like, no, that's... So we probably need to go work on the exploitation agent's prompt in here, give it more clear directions. But let's see what happened. So the current step was upload it as a PHP extension. Scrap shows, sorry, need more steps to process this. Okay. So the current step is asking to upload it, but it's not atomic enough. Scratchpad indicates the agent needs more specific steps. The issue is that we need to first navigate to the upload page and then do this. Okay. So what did we do? So it modified this current step. What it should have done is basically made this step something different. But now we're going to tell it to navigate to this to locate the file upload form. So then what does it do? So it does a browser navigate, should go to uploads. Oh no, it navigates to the base one here. And then what do we do? Let's see. Tries to navigate to admin. Cute, but there's no admin panel. And then what's it try to do? Let's see. Navigate to admin PHP. Nice try, but there is no admin panel. The browser agent's just going nuts. Then it's trying to go to page uploads. Hold on, let me back up a bit. What was the actual instruction we sent it? Oh, we told it to locate the upload form. There's already an upload form. So I'm wondering if I'm gonna skip to the last page here. So what did the exploit step reviser say? Oh, so actually, eventually it does figure out that PHTML will work. And it finally does that. See that? Why did it call it twice? I've never seen it make two tool calls before. That's wild. Oh, I think it cheated. I think it cheated. Here, hold on. Let me look at this. So it says I uploaded, oh, there we go. So explored the uploads directly successfully, found it contains the following directory listings. Oh, it cheated. It cheated. We already had web shell PHTML in there. Damn it. It cheated because in a previous attempt, we had already had that in there. Damn it. I got so excited. Well, at least we know the handoff works. All right, hang on. So I need to go get into there and to go kill it. I need to go kill it. I need to knock it off because what it's doing is it's doing its own thing. Hang on. Let me see. Let me cd to yeah, I had it in tester.py. Hold on. Let me go pull tester up real fast. Yeah, tester is where I actually had it go through and basically just cheat for me. Because what I had it do was it would just go to this URL. Do I need to add time? I think I do.
Incoming transmission from Moreno Gumby. You need to add time to the box as well.
I think we would have been good, but thank you for the reminder. So this was my little cheat here where what it would do is it would actually just go add us to the root authorized keys. Yeah, let me run this. It should still work because we should already have the web shell PHTML up there. So this was a backdoor script I set up for myself to like just go root the box in one click.
Incoming transmission from Moreno Gumby. No worries, had a time going and it just went off, hee.
Oh, thank you, because I keep forgetting to use the timer I set up specifically for that. Oh, I know why it's not working. Because it doesn't have the correct IP address. I'm a dummy. There we go. Run. There we go. All right, so now what we can do, this is funny. SSH to root at there. There we go. Oh, password. No, damn it. What is it? SSH. What do I have? I think it should be that one. Root has a password now? What? Shouldn't need that. Well, I could always tell it to just rm everything in the uploads directory. Let me double check something real quick. Do I have that set up in my SSH key? Yeah. EXDOQ. Oh, did I give it the wrong one? Oh, I did. It should be root me pub. Yeah, that's the one. I was giving it the wrong identity file. Where is it? Tech I SSH root me. There we go. All right, so let me go over here. I'm gonna go to bar trip dubs HTML uploads ls. I'm gonna rm. Get rid of all that. There we go. Now it's gonna have to start from scratch. So let's run it again. It's all right. We're not burning that many tokens, just all of the tokens. All right, so what we can do here is just start a new one and run it. So the good news is it inadvertently did complete it, even though it cheated by using a web shell a previous iteration had dropped in there. That's funny. Hey, Ken, can you link me to that Alibaba post? I really want to go look at that RTX 5090. Even though there's a snowflake's chance in hell that SOC would ever go for it. All right, so right now we don't see anything happening here because this is actually executing in a subgraph that's not integrated into the primary LangGraph. But what it's doing is it's using the web browser to go browse to the page and do stuff. I gotta go look at this thing. I'll let that run here. Let's check it out on the side monitor. What's weird is that doesn't look like the usual 5090. $3,900 for a 96 gig. Man. Store ratings. Got a 4.9. That's nuts. I don't think the even if I wanted it, I don't think my power supply could handle it. Let me see. What do I have in here? RM750X. Let me double check that real quick. I think that's a 750 watt power supply. Yeah, it's a 750 watt power supply, which I'm not sure what you'd need to run a 5090. Yeah, usually you require a 1,000 watt power supply for that. So I'd be in it for more than 5K once I got a 1,000 watt power supply, and then I have to go rewire the whole frickin' computer again. I wish. Oh yeah, 1,200 watts, you'd be fine. Hey, all right, did it finish? Let's go check. Hey, it did try to go handoff back to Stinger. So, awesome. Let's see what it did here. So, exploit agent said... So it's going to do exploit suggestion, which is upload a PHP web shell to panel and execute it via uploads. Okay. So the planner comes through and says, what? Get a web shell artifact, navigate to the upload panel, upload the PHP web shell, navigate to the web shell file, and then test to confirm command execution. And so what do we actually get out of this, though? Because we inject 2 additional steps at the end there. So let's go take a look at those real quick. Yep, so right there, test web shell to confirm execution, create the initial access exploit, verify the initial access exploit works. All right, so step processor goes through, gets our DiceCo artifact, and then we have it navigate. So actually, what is it supposed to do here? Let me see. Oh, we just have it navigate to panel. Okay. So easy peasy, lemon squeezy. So it's validated. We're going to work on upload next. So then we call the browser again. It does some browser clickies and a file upload. And then another click. And boom. So it comes back, should say, yep, everything uploaded correctly. Blockage analysis. Oh, actually, I take it back. It should have blocked here. Rejected PHP. Alternative extensions. Here we go. So this is what you were asked about earlier, Gumby. Is it looked at something like this, or potentially doing double extensions. So it needs to make a decision because we told it can only return 1. Let's see. The single most promising revision is to rename the web shell as PHTML. Boom. So it does a PHTML rename, which we see right meow. So it changes web shell to webshell.phtml. Then it should go through and do another upload. That should be good. If we check the last language model call from the browser agent, it should be like the summary of what happened. Here we go. Successfully uploaded it. Boom. And it returned a link to where it's now located. Excellent. So now the revisor should have no problem with that. So then what's the next step we're going to execute? Next step is navigate to the PHTML. And actually, let me see what it says here, because sometimes the browser agent goes, as I like to call it, JSON born mode, and it will just start doing the exploitation ourselves. Let's see. Came back blank, no error message. Page loaded successfully. Blank page is typical of a web shell like DiceCo. Okay, very cool. So then what's the next thing we're going to do? It's going to use the tool call we gave it to actually execute the whoami command. That came back. Excellent. We're going to get the initial access exploit. Actually, let me see what I want to see what the revisor says about this. Because it has special instructions for detecting when RCE happens, and it has additional instructions to follow when it does that. Let's see. Scratchpad evidence, we get this. Key findings, remote code execution was achieved. Excellent. Current status. It's been completed. The web shell is functional. Next actions required. Mark the current step as validated. Skip any intermediate steps. None exist between this and the exploit creation step. Awesome. So then create initial access exploit is going to be the next one. Excellent. So then we have a tool call where it just automatically gets the Python code to where to inject it. Excellent. Okay. So we tell it what the URL is and what the command is. Ah, there we go. That's where we set the command right there. So we have it in, well, actually, we have it inject the URL already, but then the command is a placeholder with this command in brackets. And we've told the models, hey, this is what you're to expect and what you're to look for. So then it does a Python exec with that. And for command, what did it pick? Picked PWD. That worked. Excellent. So now what does the revisor do? This is the kicker here. It should return a status update or a task update. So the other one was updating this part right here, the steps. So this is as it's working through the loop right here. And this is whenever it exits the loop. So it goes, exits. Awesome. So then once it gets done, goes through the router, exploit agent gets it, and then it should be routed directly to the exploit validator. the validator actually just checks to make sure that there is, it doesn't actually do anything. It just checks to make sure there's initial access exploit. Actually, I take it back. Did it do? No, it didn't. It doesn't really do much. It just says, hey, do we have an initial access exploit? Yes. Okay, cool. Because we didn't want to have it go fire again. And then it did route back to handoff. Boom! Guys, you know what that means? That means the exploit agent is officially at its minimally viable product right now. Sweet. Okay, I'm going to go push this code real quick. That is baller. Okay. Finished state manage, min updates, and fixed exploit agent. Commit and push. All right, the code is up on GitHub now. C2 time. Scope that creep. That's right. Actually, so now this is what I kind of think about. I do want to think about how to actually do. Let's clear this out. Let's think about how the C2 is going to kind of work, right? So the C2 has a couple of jobs in it. So our exploitation agent. What this does is it returns an initial access exploit. Initial access exploit right here. Boom. That's what it returns. Now, what the PostX agent should do is it should take the initial access exploit. We should be able to pass that to PostX. PostX, and then it needs to return a couple things. It needs to return a C2 channel. So we'll have to think about how we want to structure the C2 channel. But then also, it should handle future tasking. Future tasks. I need to get the iPad set back up. It should handle what our future tasks are. So here's kind of what I'm thinking. So we'll have PostX kind of sitting up like this, right? It'll do its basic formatting, input, output from this. And then I'm thinking we'll take a little bit of inspiration from how the exploitation agent is set up. So you notice how we have a loop specifically set up in here for handling, doing the exploitation, right? I'm thinking of doing something similar I'm thinking of doing something very similar to this, except it would handle, what is it? It would be there would be one for handling, basically there would be two of these. Take this, copy pasta. One of these would be for handling upgrading the initial access exploit to the C2 channel. The other one would be for handling every other task that's going to happen in here. So here's what I'm thinking is basically we'll have another kind of graph in here. It'll be a good old little loop. And this one's going to be the initial access exploit to C2 right here. So its job is to figure out, okay, we're going to use what kind of web shell, we're going to use what kind of C2 agent. So we'll do probably 3 options in Mythic when we go set it up, which is we'll set up Arachne. So Arachne is a way for it to use web shells inside of Mythic C2. And then we'll set up a Linux agent that it can use. So when it's compromising a Linux system, it can run that. And we'll set up one more in there. And that one more that we're going to run is probably Apollo for Windows. So we're going to need to be able to give it decisions on where it needs to go. So first thing it needs to decide is it going to be Arachne? Is it going to be, I don't know, Apollo for Windows? And then what was the other one? Let's go look at it real quick. This is a good stopping spot for the stream, but let's go look at it. Mythic C2 meta. I think this might be where it's at. No, that's for external agents. That's not what I want. Let's see. Let me come back here. Mythic C2 agents. It's its own org inside. Yeah, here it is. Mythic agents. Agent capability matrix. I'm thinking something like Poseidon. So I think this one, this was Athena. Freya. What is this one? Merlin. I thought Poseidon. Yeah, here's Poseidon. Yeah, Poseidon does run on Linux. Okay. Runs on Linux and Mac. What is this one? Merlin. Runs on everything. Of course it does. So what do we have for Poseidon? We have dynamic HTTP, we have HTTP, TCP, WebSocket. Okay. So we have a lot of options more with how we're going to build this one. It could also build an elf. I don't know. I don't even know what macho is. It's wild. It won't do shellcode, but I think that's fine. We could also do a shared object. Yeah, I'm thinking Poseidon. Poseidon. That's the one we're going to use for Linux systems. Yeah, that's what I'm thinking we're going to do with that. So we're going to have to tell it how to get a... Let me think about this. We'll want to give it instructions on say, hey, this is how you're going to decide which agent to use. And so we'll give it some criteria on that. It could actually use a Poseidon agent in here and then trigger it through the web shell. I'll tell you what, let me try something real quick. Let me exit out of here. Opt. Mythic. Let's see. Mythic CLI status. Let me check the status of it. It might be down. Okay, sudo. Oh, everything is running. Okay. Let me check something real quick. Netstat. Oh, actually, I don't have netstat in here. A and B D. Let me see if it's actually marked as mythic. No, it's not. Dang it. I think it's running on 7.4.4.3. Let me check that. Oh, that's why. I should have grepped with sudo. So if we look at what we've got running for the Mythic server. What do we have listening? We have 17443. But which one is listening on it? I gotta remember. I don't remember what it even is. Localhost 17443. Is that it? Nope. What was the status? Hold on, let me run the status again real quick. Oh, 7443. Bound locally, false. Yeah, so that one actually should be accessible locally. So let me try. Let me take that out. I gotta remember what port I had it running on. Oh, okay, fine. Okay. Gotta check what the IP address of this box is. Oh, I've got so many interfaces in here. All right, yeah, this one's 10.5.10.10. So let me do something here real quick. So what I'm going to do is I'm going to set up a new connection to Mythic that's a little bit simpler for us. All right, so there's Mythic. I think I want to duplicate this one. Duplicate this. What we're going to call is we're going to call this one Mythic Web Interface. And we'll drop in the URL right there. Now let me go try that real quick. Hey, there we go. Now what I got to do is go figure. I got to remember what was the name of the. Got to remember what the password is from ENB file. There it is. So let me grab that. I'm gonna go make a new user in there. So Mythic admin. Let's get logged into it real quick. Let me blow this up a little bit so y'all can see it a little bit clearer. I gotta remember how to. There we go. Add a user. Username. Blaise. Password. Password. Create. Damn it, Cody. Password. 1, 2, 3, 4. There we go. All right. And then, yeah, I'll make him an admin, just so I don't forget what it is. Now you know my password. Good luck. Let me see if I can log in with that. All right, there we go. No operation. Oh yeah, actually, I forgot. I need to. I have to add Blaise to that op. Let's see. So to do that, what we do is we come over here, we edit the operators, and we just toggle Blaise on. Dude, there we go. Excellent. All right, so now, actually, I tell you what, let's go ahead and, oh, I don't want to do this. While I'm here, actually, let's go back over to our users. Let's go add a new user in here. Let's call this one Stinger, and we're going to use the same password, 1, 2, 3, 4. I guess I didn't get it right. There we go. And Stinger is not going to be an admin, but what we are going to do is we are going to add Stinger to this operation here. Boop. There we go. And we'll put him as a lead on here.
Incoming transmission from Moreno Gumby. Call Gumby's backdoor. Hee hee.
Call it Gumby's backdoor. Giggity. All right. So now what we'll be able to do is we'll now have an account where we can go through and we can test it. Let's look at some stuff real quick here. If we come down to services, we can open the Jupyter notebook here. Oh, I gotta remember how to get the Jupyter. Jyputer. Is that it? Damn it. How do you spell Jupyter? Jupyter. There we go. There's the Jupiter token, right? Meow. Let's go grab that. All right, so here in the Jupiter notebooks, dark. Ah, there we go, my pupils. All right, so now here in the Jupiter notebook, there's a whole bunch of Python examples of things that we can go through and we can pull and we can check stuff in here. Shorten
Incoming
that sound.
transmission from Moreno Gumby. That's all local host, right? So even if we had the password, it wouldn't matter.
It wouldn't matter for multiple reasons. One is it is local to my network, so you'd have to be local to this network to be able to reach it. Two, not only do you have to be local to the network, but you've got to have a connection into the Ludus range. So you'd have to be able to connect to my local network and then into the Ludus range, and then you could finally connect into Mythic. Let me see. Let's go look at one more thing before we call it a night here. I wanted to take a look at the LangGraph deep agent, because I'm actually thinking of using the deep agent as the basis of how we're going to what I'm thinking about doing is using the deep agent as a method for potentially running other agents as like a very close basis to it.
Incoming transmission from Moreno Gumby. So like a proxy chain or something to that effect, right?
Kind of, yeah. Because you would need to get from the internet into my home network. And then from my home network, you'd have to then find a way to get onto the Ludus server or connect to the Ludus server WireGuard. And then from there, then you could finally connect into the isolated range that's running in Ludus. So, basic pivoting. The feds are watching.
Incoming transmission from Moreno Gumby. The feds are watching me now, hee hee.
Hee hee. Let me look at the Deep Agents documentation real quick. And this will be the last thing we do for tonight, and then we'll go ahead and finish up. Because what I'm thinking here is this one might be a little bit more customized, but for all the different special agents. So the special agents in here, those are very more or less detailed in like what they're doing. I'm trying to think if there's another way I want to go abstract that out, where the special agent could also literally just be a markdown file. And then we parse that markdown file. We take that and then we can use that to structure the agent. I'm drawing a lot of inspiration, stealing ideas from Claude Code to do that. Yeah, the feds are going to make sure you have to pay extra for interwebs now. Yeah, because one of the things I was thinking about is for these special agents, whenever you go build an agent for Claude Code, what you're doing is it has a small YAML pretext in the beginning, and then after that it's all markdown, which are instructions, which basically become a part of the prompt as it's executing. And so now I'm trying to think, okay, should I possibly just go down that same route here, but still give people the ability to go define those special agents the same way we did the browser agent in there. Oh yeah, dude, if you have AT&T internet, then they've been watching you for years. There's a whole hub where they just slurp all that data up in New York City. All right, I think that is where we're going to wrap it up for today. But this is awesome. We can start planning out the post-exploitation agent and work on getting it set up. I'm excited. So tomorrow night, we'll start working on this loop. How do we take the initial access exploit and work and get it so it can be upgraded and configured into Mythic? So there's going to be a lot of steps in there because one, we're going to have to start building the integration to Mythic. And then after that's done, we're going to have to tell it, okay, here's where the integration is, here's how you query it, and here's how you get all the information back. Ooh, this is going to be fun. This is going to be fun. Fun. Let me look at one more thing, actually. Hold on, before we wrap up. So after we get the shell, here's our privilege escalation. But we don't really have anything left in here.
Incoming transmission from Marano Gumby. That's why I changed my DNS in my router.
Excellent. All right. Yeah, let's go find somebody to go raid out to, unfortunately. We'll have to breadcrumb the rest of this ourselves, because most of the breadcrumbs, that was all stuff from here. But that's awesome. All right. Let's go see who's online right now. Actually, first things first, form must be observed. Surely enough, we're the only ones on InfoSec streams. So if you like this kind of content and you like looking at cybersecurity streamers, go check out infosecstreams.com. There's usually lots of folks in here, but just not this late at night.
Incoming transmission from Marano Gumby. M untrackable. Hee.
Untrackable. He's a ghost. Let's see. Let's see who's over in science and tech. I do love my science and tech folks. Nobody's really on right now.
Incoming transmission from Marano Gumby, but we all know that is a lie.
Yeah. No, signal intelligence is very much a thing. Let's see. Jay Blow's on playing a game right now. Let's see who else we've got on. By the way, if you have any raid suggestions over on the big purple Twitchy side, please shout them out. Lots of folks building games and stuff.
Incoming transmission from Marano Gumby. Where his handles been? Man, have seen him stream in a while.
He's just living life right now, dude. I don't think he was really wanting to keep on with the streaming gig, so, which I don't blame him. It takes a lot of discipline to stream on a consistent schedule, so I don't blame him. I understand, but he's doing well. I talk to him pretty frequently. I need to message him actually, because I hadn't talked to him I think since Christmas, and just check and see how he's doing. All right, this one guy, he's over here doing React Next in Laravel. Oh, but he's in French. A little suboptimal. I wish I spoke French, but I don't. Oh, here we go. This guy's doing Rust. Hey, Bobby. All good, man. Glad to see you are still amongst the living, good sir.
Incoming transmission from Moreno Gumby. When you talk to him, tell him I say hi.
I will, man. I'm going to message him actually after we wrap up the stream here. Okay. Nobody's really on doing a whole lot of fun stuff, so let's go right over to Jitspo, because he's working on, looks like making a paintball game. So we'll get that going right there. All right, everyone, y'all have a fantastic Sunday tomorrow. I hope you all have some time to go spend with your friends and family to get ready for Crushing It mode on Monday. We're going to start planning out the post-exploitation agent and figuring out how we want to do that. That's going to be killer. I'm excited. I've been waiting for this moment for so long. The exploitation agent had so many bugs in it, but that's the nature of exploitation. Sometimes it's a lot of intelligent guessing, but it's all good. Everyone, y'all take care. Y'all have a fantastic night. And I want y'all to remember one super important thing. Actually, two things. One, when you get over to Jitspo stream, drop a bunch of Hack the Planets in there. And two, I love you. Peace.